So continuing in section 1.2, we're on page 13. We're going to talk about this thing called composition of functions. To compose two functions means to put one inside the other. Here's what's going on here. I've got two functions, f of x equals x minus 2, g of x equals x squared. I want to find f of g of 3. What this is telling us is I want to go find g of 3. Plug 3 into the g function, get an answer. Once we have that answer, I'm going to plug that answer into my f function. Let me make a couple notes over here. To deal with something like this, I'm going to start on the inside and work your way out. Start on the inside and work your way out. F of g of 3, I'm going to start on the inside and work my way out. So in the inside, I have g of 3. Let me go take a moment and find g of 3. G of 3 is just going to equal 3 squared, or 9. I'm then going to take that answer, and I'm going to plug that into the f function. I'm going to get f of 9. Well, what's f of 9? F of 9 is 9 minus 2, or 7. I'm going to start on the inside. I'm going to plug 3 into my g function. I'm going to get an answer. Then I'm going to plug that answer into the f function. By the way, why would we ever care about this? Right now, we're just going to see how to do this, but at the end of this video, I'll give you an example of why we would ever plug the answer to one problem into another problem. There are some good applications of that. Let's take a look at letter B. I'm going to start with that 5. Now, what should I plug that 5 into? The f function or the g function? I think I should plug 5 into the f function. F of 5 is going to equal 5 minus 2 is going to equal 3. I'm then going to take that answer. I'm going to plug that answer into my g function. I'm going to get 3 squared. I'm going to get 9. By the way, I'm perfectly fine with you just writing 9 for the answer. If you want to be more technical, I suppose you could say g of f of 5 equals 9. That would also work. What I don't want is g equals 9, f equals 9. That doesn't mean anything. Either just give me the number or give me the entire problem equals 9. You go try a couple of these. New functions down here. Go do letter A. F of g of 1. I'm going to start on the inside. I'm going to find g of 1. G of 1 is 2 minus 3 times 1. Well, that's 2 minus 3. That's negative 1. I'm going to plug that into my f function. So f of negative 1, negative 1 plus 1, we're going to get 0. Go find g of f of 1. I'm going to start on the inside. F of 1, 1 plus 1, that's going to give me 2. G of 2, 2 minus 3 times 2. 2 minus 6, I'm thinking negative 4 from that one. G of 2, negative 4. Notice f of g of 1, g of f of 1, same letters and numbers and stuff, but very different answers. You will not get the same answer. The order makes a difference. It matters if you first plug one into the g function, then the f function, or if you first plug one into the f function, then the g function. Try letter C. What's f of h of 3? I'm going to start on the inside. H of 3. H of 3 is, let's see, 3 squared plus 2. 9 plus 2, that's 11. F of 11 is going to be 11 plus 1, or 12. Go to letter D, G of f of 5. Start on the inside. F of 5. F of 5 is 5 plus 1, or 6. Plug that into the g function. G of 6 is going to be 2 minus 3 times 6. 2 minus 18. We're going to get negative 16 out of that. Well, we can plug in numbers. We can plug in variables. We can plug in answers to other problems. And finally, we're going to see we can plug in entire functions to other functions. Turn the page, page 14. Same three functions. I want to find f of g of x. Well, I'm going to start on the inside, and I'm going to plug x into the g function. And I'm not going to think too hard, because if I plug x into the g function, I just get the formula 2 minus 3x. This is going to give me the problem f of, what is g of x? 2 minus 3x. I want to plug this expression, this 2 minus 3x, into my f function. Well, when I go to do that, I'm going to get 2 minus 3x plus 1. There's really no need for the parentheses, so I'm just going to drop them at this point and say 2 minus 3x plus 1, and I'm going to get 3 minus 3x. In letter B, I want to do g of f of x. What's f of x? X plus 1. So this problem becomes g of x plus 1. We're going to go and plug x plus 1 in where the x was. I'm replacing the single x with the more complicated x plus 1 in that g function. I'm going to get 2 minus 3 times in parentheses x plus 1. Take a moment, clean that up, distribute the negative 3. Tell me what the simplified answer is. Distributing negative 3, I get 2 minus 3x minus 3. That is negative 1 minus 3x. In letter C, f of h of x. This is f of x squared plus 2. See if you can go from there. What are you going to get for letter C? Okay, x squared plus 2 plus 1 is going to give me x squared plus 2 plus 1. There was no need for parentheses because nothing to distribute. We should get x squared plus 3. The next one, I want to do h of f of x, which is h of x plus 1. I'm going to plug x plus 1 into the h function. So I'm going to say in parentheses x plus 1 squared plus 2. Hopefully you remember, what do we have to do to square x plus 1? Hopefully you're remembering we need to write it out twice and FOIL, or distribute. X plus 1 times x plus 1 plus 2. Well, x times x is going to give us x squared. X times 1 is going to give us x. X times 1 is going to give us another x. 1 times 1 is going to give us 1 plus 2. Cleaning this up, we should get x squared plus 2x plus 3. Take a look at letter E. See what you can do in letter E. This is g of x squared plus 2. This will give me 2 minus 3 times in parentheses x squared plus 2. I'm going to distribute the negative 3. 2 minus 3x squared minus 6. That's negative 4 minus 3x squared. Before we move on, let me just copy down the h function and the g function so we can see it on the screen at the same time. G of x equals 2 minus 3x. H of x equals x squared plus 2. See what you can do in letter F. What do you get for letter F? H of 2 minus 3x. That's 2 minus 3x squared plus 2, which means write it out twice and distribute. 2 times 2 is 4. 2 times negative 3x is negative 6x. 2 times negative 3x is negative 6x. Negative 3x times negative 3x, positive 9x squared plus 2. And we'll combine like terms and get x squared minus 12x plus 6. Try letter G. In G, we're going to get G of 2 minus 3x. This becomes 2 minus 3 times 2 minus 3x. I'm going to distribute the negative 3, so 2 minus 6 plus 9x, and we're going to get negative 4 plus 9x. So before we move on from this, I do want to spend a moment talking about why we actually care about this function notation stuff, f, g, h, why we would ever plug the answer from one problem in somewhere else, why we'd ever plug an entire function in somewhere else. In Google Classroom, there should be a sheet titled Section 1.2, an application of functions / composition. If you have a printer and can print that out, please go do that. And if not, you can just take a look at this on the screen. But I'd like you to take a moment, print this out or just take a look at this, and see what you can do in problem number 1. That function f changes Canadian dollars into American dollars, and the function g changes American dollars into Mexican pesos. I have 5 Canadian dollars. I want to figure out how much that's worth in American dollars. That means I need to plug that 5 Canadian dollars into my f function. And I need to go do the problem f of 5. Well, what is f of 5? It's going to be 0.76 times 5. You're going to want a calculator for this. 0.76 times 5 should give you 3.8. But that's not how we write things in dollars. We're going to say $3.80. You have 5 Canadian dollars. That'll be worth $3.80 in American dollars. I'd like you to try number 2, and I want you to start number 2 by writing it out in function notation. Write it in function notation, and then tell me how much 10 American dollars is worth in pesos. I want to find g of 10. This means 20.41 times 10. It's going to be 204.1. Just like dollars, we should use 2 decimal places with pesos. So I'm going to say 204.10 pesos. Number 3, I have 4 Canadian dollars, and I want to know how much this is worth in Mexican pesos. We don't have a formula that goes from Canadian dollars to Mexican pesos. So without a formula, how could I do number 3? Well, I can't go from Canadian dollars to pesos, but I think I can go from Canadian dollars to American dollars, and then American dollars to Mexican dollars. How would you convert Canadian dollars to American dollars? With the f function. We can say f of 4. And our answer is going to be in American dollars. If I then want to convert that to pesos, I'm going to take that answer and plug that into my g function. And I'm going to get the composition problem, g of f of 4. Go find that. Convert 4 Canadian dollars to Mexican pesos. Okay, so f of 4 is 0.76 times 4. That's going to give us $3.04 in US dollars. I want to then convert $3.04 in American currency to Mexican pesos. That means I'm going to go do 20.41 times 3.04. 20.41 times 3.04, and I'm going to round to 2 decimal places here. That's going to give me 62.0464, rounding to 2 places though, 62.05. Now, this wasn't a big deal to convert 4 Canadian dollars to Mexican pesos, but if then I wanted to convert a whole bunch of other Canadian dollars to Mexican pesos, convert $7 Canadian dollars to Mexican pesos, or 9 Canadian dollars to Mexican pesos, or a bunch of other problems, this is not going to be the most efficient way to do it. It would be great if I could create a formula that would do that. Any idea how I could create a formula that would convert Canadian dollars to Mexican pesos, and maybe use how we started 3 to get you thinking? Well, rather than finding g of f of 4, I'm going to find g of f of x, because f of x takes Canadian dollars into American dollars. My answer to an f of x problem is in American dollars. Why don't I plug that answer into the g function to get a Mexican peso thing out of that? Go see if you can find g of f of x. What is g of f of x? F of x is 0.76x. I'll plug that into my g function, and I'm going to get 20.41 times 0.76x. 20.41 times 0.76 should give me 15.5116x. And I think I'm actually going to leave all the decimals. I know we'd round our final answer if it was an actual number, but here, because it's just a formula, the more decimals will make it a little bit more accurate, and then we can just round whatever number we plug in. So I guess at this point I could have redone problem number 3 by plugging 4 in here. I should get 62.05. Let me try that. 15.5116 times 4. 15.5116 times 4. Oh, hold on. I'm sorry. You can't see that. Sorry about that. You're going to get 62.0464. Yeah, which rounds to exactly what we had in number 3. Just another way of doing that. In number 3, we just worked with the numbers, but in 4, we created a function for this. Just one application of why we would ever do a problem and then plug the answer into another problem, or plug an entire problem into another problem.